All right, 4.7 today, solving these equations by factoring. So we have an extension of what we learned while we were factoring that we're going to apply here. All right, first of all, let's talk about the standard form of a quadratic equation. That's what we're going to be solving our quadratic equations for the most part. And the form of that is ax squared plus bx plus c. And if you notice that equals 0, this is the variables raised to the powers now are in descending order. So we want to make sure we do that when we're setting up our problems to solve them, that they're always in descending order. It's a big help. Okay? A is any number other than 0, B can be 0, and C is a constant in our standard form. All right, and all equations can be written in this form in a creative way, and I'll demonstrate that later on. Okay, so we've got the standard form of the quadratic equation, and that's what we're going to be solving now, in equations that's similar in this form. All right, so for example, I'm going to have our first example, which is the practice problem. And that's practice problem 1, which is x squared minus x minus 6. And notice I've got it equal 0 now. So this is what's new in this section about solving these quadratic equations. I have to get it equal to a number now. It will be coming to us. And I got to know what to do with that. All right. So things remain the same as we learned as far as factoring, though. But now we got to get each of the factors equal to 0 at the end. And I'll show you what I mean by that, like right now. So here's my quadratic equation. It's already set up in descending order, and it's equal to 0, which I always want to do. I want to get any equation and set it equal to 0. This is already equal to 0, so I don't have to do anything with that. If I had a number over there other than 0, let's say if it were 1, then I would subtract 1 from both sides and get it equal to 0. Okay? All right, but it's not, so let's take it for what it is. So now here in my world, I like to categorize the type of problems that I have. This I'm going to call an easy problem. And I call it easy because the first term has a coefficient of 1. Okay, I can't, it is 1, so I'm just going to leave it as it is. If the lead coefficient is 1, then that makes it to be an easy problem. I can set up the parentheses and fill it in. Okay, if I do that, then what do I know? I know that x goes here and x goes here. I'm going to copy down this sign, that whatever's in between the first and second term, and put it here. And then based on what this sign is for the constant will help me decide what sign goes here. So I'm predetermining what my signs are. So if this is negative and this is negative, that means this sign has to be positive. And why? Because a negative times a positive is this negative when we're multiplying that together. Okay, I want you to be clear about that. Make sure you understand what I'm talking about. Some of you may be going, oh, what? Because it's maybe backwards to you. And it very well could be, and there's nothing wrong with that. It's just the way I'm going forward with this in my explanation. Remember, my two signs got to equal what the sign would be here for the constant in the quadratic function. Remember, this is x squared, what is that? Minus x minus 6. So in other words, a negative times a positive is going to be this negative here. When I do FOIL, the L in FOIL, the last terms, when I multiply them. All right, so now I've got negative 6 here is my number. And what are two numbers that will equal, what numbers are going to give me that negative 1x in the middle? All right, so it would have to be 3 and 2 with the 3 being negative. All right, so then the 3 goes here and the 2 goes here. The negative's already written for me by way of copying down my signs. All right, so I got x minus 3 and x plus 2. But remember now, it's equal to 0. Okay, so I've got, think about it, x minus 3 times x plus 2 equals 0. So remember, these are factors now in the parentheses. So I want to get each of them equal to 0 to give me my result. And hopefully you won't have to do this very long. But the way it goes is I'm going to put x minus 3 and get it equal to 0. And how about x plus 2 and get that equal to 0? Now I can say, what does x have to be for this to be true? Well, if I add 3 to both sides, I would have x equals 3. 3 minus 3 is 0. Okay, so that's one answer here. This answer, I'm going to subtract 2 from both sides. And when I do, I get x equals negative 2. And that's my answer, the second answer. All right, so I have two answers indicated by the variable raised to the second power. It's a quadratic function raised to the second power, so I could have two answers. And that's what indicator, that's what that means. And that's just for informational purposes. All right, so our first one is done. Here's practice problem 2, and boy, does that look like a doozy. All right, when I have problems where there's fractions involved, especially in this section when we're solving quadratic functions, I want to clear the fractions out of there. Okay, I want to get rid of the fractions. So how do I do that? Well, I'm going to multiply everything by the LCD of 2, 6, and 3. So I'm looking for a number that 2 will go into, that 6 will go into, and 3 will go into. And it looks like it would be 6. So I'm going to multiply each of these terms by 6. Really important concept we're learning here. All right, so I'm going to use green here, and I'm going to box these up. Nice little package here, so we can see better what's going on inside each of the boxes, because I am simplifying that. Okay, so it's going to be 6 times 1/2. Well, that's going to give me 6 over 2, and then 6 divided by 2 is 3. So I get 3x to the third power equals, and then I'm going to simplify box number 2 here by going 6 times 5 is 30 divided by 6, which is 5x squared. And then I've got a plus sign here, and I'll simplify box number 3. 6 times 1 is 6, divided by 3 is 2, and that makes it 2x. Okay, then I'm going to scroll up here. This is my equation now that I have to solve for x. All right, so as you can see, I've got x cubed, 5x squared, plus 2x. I want to get all this equal to 0. So that means I'm going to subtract 5x squared and subtract 2x from both sides. All right, so that'll mean my left side's going to be 3x cubed. And if I'm subtracting 5x, that would be minus 5x squared minus 2x. And now it's all going to equal 0. I brought these two guys over to the left, so there's nothing on the right-hand side. And this is where I'm at now. Now I'm going to factor out anything I can factor out. So with this, I can factor out just the x, one x it looks like. If I got 3, 5, and 2, I can't factor anything out. But then with my variables, I got x cubed, x squared, and x. Well, we're back to the smallest one comes out, the smallest exponent of the variables. So I'm going to bring the x out front and then divide back what's left over. When I divide back what's left over, I'm going to have 3x squared minus 5x minus 2, all equal to 0. All right, since that's factored now I want to look at the trinomial that's left inside the parentheses and factor that, if I can. All right, so let's check it out. My x is outside of the parentheses, so I'm going to leave that alone. So here I've got 3, and I can't factor that 3 out, which we already determined, so I've got to do the grouping method now. All right, this isn't the easier one. Well, grouping's easy, but it takes a little more time. All right, so what do I do for the grouping method? I start by multiplying a times c, so that's 3 times negative 2 is negative 6. I want 2 factors of negative 6 that'll add up to be negative 5. All right, and so that must be 6 and 1, where the 6 is negative. Negative 6 plus 1 is negative 5. Got to let that arithmetic work for you. It's got to work that way. Negative 6 times 1 is negative 6. Negative 6 plus 1 is this negative 5. All right, so my critical point next is to rewrite the problem into that 4-term polynomial. Okay, so I'm going to have 3x squared minus 6x plus 1x minus 2. Okay, remember, we got to bring this down with us afterwards. So I'll just circle that and bring it down at the end of the problem. All right, so here's where I've got a 4-term polynomial that I'm going to now factor. That's why we do this, get into a 4-term polynomial, and I'm going to factor each of these binomials. So let's do that. Here on the left side, I'm going to have 3 come out as well as an x. And then what's left? 3x squared divided by 3x is x. 6x divided by, negative 6x divided by 3x is negative 2. Okay, here's my plus sign. I just copy that down here. The right side, I can only take out a 1, so I want to write that 1 so it doesn't get lost and I miss it. I want to be able to see it. And then what's left is, well, x minus 2. When I factor out the common binomial factor here, let's change colors to something else, maybe blue. I've got a x minus 2 here and an x minus 2 here. They're common, so I'm going to factor that out, x minus 2. And when I factor that out, I cross them out, and I say to myself, what's left over? 3x, here's the plus 1. That's why it's critical that you factor out the 1 so you see that. If I didn't see that, if I said, well, nothing factors out of x minus 2, then you're just going to write 3x, and then your answer will be wrong. Okay, so I've got 3x plus 1 is left, and that goes 3x plus 1. And then lo and behold, I'm not going to forget my x up here, and I'll bring that down as part of my answer, where it equals 0 now. And I am still not done, because now I got to figure out what values for x will make this true. Well, this first x that I brought down, it's on the outside. If x were 0, then it would wipe all this out, right? If x were 0. X, 0 times this would be 0, and 0 times this would be 0. So one of my answers for x is going to be x equals 0. Okay? Then I've got x minus 2 equals 0. Well, I could set it up here and say x minus 2 equals 0. And what is x going to be? Well, I'll add 2 to both sides. So x equals 2 is my second answer. X equals 2. Okay, and the last one here, I've got 3x plus 1, and I'm going to get that equal to 0. 3x plus 1 equals 0. And I'm going to solve for x. Subtract 1, first of all. Then I've got 3x equals negative 1. And let's see, I'll divide now. Let me scooch that up a little bit. Divide both sides by 3. And my answer becomes x equals negative 1 over 3. And that's my third answer. X equals negative 1 over 3. All right, in this problem we had 3 answers because in our original problem to begin this, it was this here. And notice I have 3x to the third, so that's telling me, indicating to me I'm going to have 3 answers. Not all the time, but most of the time this works out to say, oh, I've got 3 answers. I could have 3 answers for that problem. And that's the indicator of that. And I do. X is 0, x is 2, or x is negative a third. Okay. Pretty tough problem there, I'd say. All right, at the bottom of page 396, you've got solving an equation by factoring and a generalized procedure for doing that, how to. And make sure you read that over and keep that with you. Okay, always little helpful things. All right, next problem. All right, in practice problem 3, we have this quadratic equation. All right, this has 2 terms in it, but I want to get it equal to 0 first of all. So that just means I'm going to subtract this 500x from both sides. Okay, these are unlike terms here, 100x squared minus 500x, so I'm going to write it up like this. And now it's equal to 0. Okay, and now I want to factor the left side. Let's see, I got 100 and 500, so the LCD is 100. And an x squared and x, I'm going to take out the x to the first power, which is here. Then I'm going to divide back what's left over. When I do, I'm going to have x minus 5. Okay, and when I get it equal to 0, now I can get my 2 terms that we have in the problem equal to 0. So this one, I'm going to have 100x equals 0, where now I have to divide both sides by 100. So x will equal 0, which is quite obvious when you look at it. 100 times x equals 0. Well, what can x be? It can only be 0, right? It can't be any other number for it to equal 0. All right, and then the x minus 5, I'm going to get that equal to 0. And hopefully you'll be able to look at that and tell the answer. X minus 5 equal to 0, and you're solving for x. You're going to add 5 to both sides. And so x is going to equal 5. And those are your 2 answers. X equals 0 and x equals 5. Notice the process, what I'm doing. Taking my time, get it equal to 0, factor the left side, and it gets redundant after a while where you're like, oh, this is very cool. What's really helpful is if you know your facts without using the calculator. The calculator will bog you down some. All right, nevertheless, let's move on to our next problem. Okay, in this problem, this is one of the tougher problems. I've got these two factors of x plus 1 times x plus 2 equals 12. All right, I wish that were 0 over there where that 12 is, but it's not. So I got to deal with the 12. And I could deal with the 12 by subtracting 12 from both sides. If I subtracted 12, well, the left side would look like this. It would look like x plus 1 times x plus 2 minus 12 equals 0. So we got the equation equal to 0, and now I have to lump all these together. I have to get these together somehow, this left side, because of that minus 12. I have no way incorporating that until I get the constant by itself. And the only way to get the constant by itself on this left side is multiply x plus 1 times x plus 2. All right, when we do that, I'm going to have x squared plus outside is 2x plus inside is 1x, and last is 1 times 2, which would give me 1 plus 2 is 2, and then minus 12 equals 0. Now I want to combine all my like terms here. So when I do, I'm going to end up with x squared plus 2x plus x is 3x, and then 2 minus 12 is negative 10. That equals 0. See how nicely that came together? And they do. They come out and blend very nicely, as long as we know what to do. And that's what this is for. This is what I'm doing, showing you. All right, so now I've got my quadratic equation in descending order. The equation's equal to 0, and now I want to factor. This is the easy one because the lead coefficient is 1, and let's factor it. X positive times what is a negative? Negative. Positive times a negative is a negative here. Okay, so that's right. And then I've got factors of negative 10 that add up to be positive 3. Well, 5 and 2. And which one of these numbers is going to be negative? I need a positive 3x in the middle, so the 2 must be negative. So I'm going to put the 2 with the negative in the parentheses here and the 5 here. Okay, and now I can solve it. For this factor of x plus 5, x has to equal negative 5. And for this parentheses, x minus 2 equals 0, so x has to equal 2. Done. Okay, next on, let's roll on. Practice problem 5 is next. All right, people. This problem here, I've got a 4-term polynomial. 1, 2, 3, 4. So I'm going to start it by grouping them. And if I see anything faltering or it doesn't work, then I'm going to look for something else. But right now, I'm going to just factor each of these. So the left side, I can take out a x squared. And what's left is x plus 5. Okay, I got a minus sign here. And here I can take out a 4. This right side, that right binomial, I can take out a 4. If I take out a 4, what's left over is x plus 5. Okay, I'm going to take out now the common binomial factor of x plus 5. Let's take that out, x plus 5. And then I'm going to say to you what's left over, and it's x squared minus 4. Remember, all this is equal to 0 as we go. We can catch the 0 at the end, but don't forget it. All right, so now I'm looking at this x squared minus 4. That looks a little different. Can I do something with that? And the answer is yes, I can. I can factor the difference of two squares. All right, so this will end up being, what's that? What happens when you have a difference of two squares? Well, you have your parentheses, and one sign is going to be minus, the other is going to be plus automatically. And then I'm going to have an x here and an x here. Then my numerical values for the constants are going to be what? 2 and 2, right? And then I have my x plus 5. I'll bring that down. Now everything's factored and it's all equal to 0. What will make this true? What numbers will make this statement true? Well, for the first one, when x equals, what number will make that 0 in that parentheses? Well, it would be -5, when x equals -5. The second parentheses, when x equals 2. And the third parentheses, when x equals -2. And here are your three answers, which is indicated at the beginning of the problem again by, where's that problem? Here's the original problem before I inserted the parentheses. It was x to the third telling me I'm going to have three answers. And there are my three answers. Nice. Okay, check out practice problem 6. And there it is. And it looks huge. So what do I do with something like this? Well, what I've got to do is I've got to multiply everything together. I'm going to do that on both sides. Okay, I'm going to multiply this left side first. And what would that be? Carefully do it. So it's going to be 3x squared. I'm using FOIL. First, outside, inside, last. 3x squared minus 12x. 3x times -4 is -12x plus 1 times x, which is plus x. And last is 1 times -4, which is -4. Okay, if I combine my like terms, I end up with 3x squared minus 11x minus 4, and that's going to equal the right side. So now I'm going to FOIL the right side. And here I'm going to have, let me change colors here. Here I'm going to have x times x, and that's going to equal x squared. I'll put my equal sign here to separate the two. X squared, outside is plus 3x. Inside is -3x. And last is -3 times 3, which is -9. I'll combine my like terms in the middle, and those cancel each other out, so I'm left with the right side of x squared minus 9. All right, that was a difference of 2 squared in my answer, and here's my x minus 3, x plus 3. That kind of checks out in my head. All right, so this is where we're at, this bottom line here, and now I'm going to get my equation equal to 0. So I'm going to get rid of this right side. And how do I do that? I'm going to subtract x squared, first of all. And what do I get? I get 2x squared minus 11x minus 4. That equals -9. Okay, then from here I'm going to add 9. So I get this equation equal to 0. Adding 9 to both sides. So how about 2x squared minus 11x plus 9 minus 4 is 5. And now it equals 0. And this is what I solve for. And it looks like I'm going to have to use the grouping method, because I can't get rid of that 2. I can't factor that out. So I've got to do A times C. 2 times 5 is 10. 2 factors of 10 that add up to be negative 11. All right, so that's got to be 10 times 1. And when I add it up, it's positive 11, but I need it to be negative 11. So it would be negative 10 and negative 1, because negative 10 times negative 1 is positive 10. So here are my 2 terms that I'm going to use, my 2 factors. And now I'm going to rewrite the problem to be 2x squared minus 10x minus 1x plus 5 equals 0. I successfully created my 4-term polynomial, and now I'm going to factor this. The left side I can take out a 2x, and then what's left over is x minus 5. Minus sign comes here, and I'm going to divide, I'm going to take out the 1. Remember, I need to take out that 1, and then divide back what's left over, and that would be x. 5 divided by negative 1 is negative 5. Okay. Still equal to 0, but I got to factor out that common binomial factor now of x minus 5. And that's gone now. I factor out the x minus 5, and what's left over is 2x minus 1. Both equal to 0. So I got x minus 5 here, so x has to equal 5, positive 5. And for this one, well, this is a little different, so I'm going to write it out and be 2x minus 1 equals 0, and solve for x this way. So I'm going to add 1 to both sides. And how about 2x equals 1? Divide both sides by 2. So you can see x is going to equal 1/2. And there's our 2 solutions for that problem. That was huge, that problem. Very huge. All right, let's go on to our next objective, which is saying solve polynomial equations by factoring. Oh, these are little story word problems. Okay, give me a minute. All right, let's change gears a little bit, and we're going to be solving little word problems now, or application problems, which can be a little on the tougher side, but let me help you understand what we have to do to solve these. All right, here we go. I've got one integer is 3 more than another. The sum of their squares is 29. Find the 2 integers. All right, so we got to set up the facts here, basically. We could look for 1 equation, 2 equations to sum up our problem, and then take it from there as to what we've got to do. All right, so example. So here's our first problem. I'm going to read it. If you don't quite understand it, we read it a second time. Okay? Okay. So we read the problem, reread it until we understand what's happening. And now I'm looking for an equation or maybe 2. And it's broken up by sentences. All right, an equation could be in a sentence. And there's like 2 sentences here. So I've got one integer is 3 more than another. All right, so if I've got one integer, I'm going to call it x. Is means equal sign. So one integer is 3 more than another. So then that would mean on the right side it's going to be x plus 3 because it's 3 more than another of the one integer. All right, so this is my first equation out of this first sentence there. One integer is 3 more than another. The sum of their squares is 29. The sum of their squares. All right, well, this is one number, and here's the other number. So the sum of these has got to equal 20, the sum of their squares. So I'm going to rewrite this to be x squared, the sum meaning its addition, x squared plus x plus 3 squared. And that is 29. The sum of their squares. Find the two integers. All right, so I've got x, one integer is 3 more than another, then the sum of their squares is 29. So this now is our equation. And I got to solve that now. So I'm going to have x, so I got to multiply this out. I've got x plus 3 squared. I'm going to multiply that out first. So I'm going to have this x squared. I'm going to bring it down here. And then I'm going to multiply this out. So that's going to be x plus 3 times x plus 3. That's what this means when it's squared. That binomial squared is x plus 3 times x plus 3. When I multiply that out, I get x squared plus 3x plus 3x on the inside plus 9. And we know it equals 29. Combine my like terms, and I'm going to have this x squared I'll bring down here, plus this x squared, plus 3x and 3x, well, that gives us 6x plus 9 equals 29. Combine my like terms up here, I'm going to have 2x squared plus 6x plus 9 equals 29. And now here's my quadratic descending form, and now I want to get it equal to 0. So that means I'm going to subtract 29, both sides. How about 2x squared plus 6x minus 20? Is that minus 20? 29, 20, negative 20. Yeah. Equals 0. And this is my problem so far. Okay. So now it looks like I can factor out the 2 here. I can factor out a 2. If I take out a 2, then I have x squared plus 3x minus 10 equals 0. Okay, and now I'm going to factor what's inside the parentheses. This 2 is just out. I don't have an x with it, so it's just a number, so I can just ignore that now, because I'm solving for x. If I had an x with the 2, then I have to keep it, because the x would probably need to equal 0 at the end of the problem. All right, let's factor this. All right, this is the easy one, because the lead coefficient is 1, and I'm going to get it to equal 0. So how about an x here, bring down my plus sign here, and determine what this sign is based on what this sign is. So this sign here has to be negative. Okay, my number is negative 10. I need two factors of negative 10 to add up to be positive 3. And again, that's 5 and 3. No, 5 and 2, sorry. Okay, which number is going to be negative? It's going to be the 2. So I'm going to put the 2 here and the 5 here. And now we can answer the problem. For this x plus 5, x will have to equal negative 5. And for this value here, let's see, did I do that right? Negative, yeah. And this one here would be x equals 2. One integer is 3 more than another. The sum of their squares is 29. Find the two integers, and that's where they're at. Very nice. That was practice problem 7.